Yo, 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 what's up, everybody? New week, but still old system we're trying to get in place. And I think we made some very nice progress last week, especially or specifically on Friday. So the current state look like this pretty much. So we find the minima and then we fill up from there slowly but surely. And if this one overflows, we will just dry the water back after we have stopped the animation. Although I'm a little bit questioned about this one right here. Is this because water 100, water 100? Actually, this one has height 99 but water 100, but we're still not seeing the water. And I know why. We have a, let's see here. The water panel is lowered a tiny bit in the shader just to avoid for said fighting. So when the water amount and the ground amount, or water height and ground height, is the same value, we don't want them at exactly the same place, but we want to offset the water a tiny bit. So this is what it actually looks like. So I think we need to probably need to lower this the offset a tiny bit, although still have this issue with the visuals here, which is a bit unfortunate. Yeah, it's a question of how we want to handle this exactly. So here we have water 72, and then we want to move from here to here. We want to move upwards, so we don't want to lower it or anything like that. And we just put it to as much as this one has, which gives this result. I wonder if we can improve upon this in some way by taking this value, maybe 39. I remember us having a problem with this one with the previous implementation as well, or yeah, they're pretty much the same. But how exactly to handle this? Water 52. If we lower this water value, it's not going to do anything but, I think, highlight this corner even more. Or actually, what we can see here is, here we have a pretty nice edges. I wonder, is it the fact when we're moving? Yeah, we get this result when we're moving downwards. I would say, what do we have here? Water 100, water 100. Last time we discussed this problem, we had, you pretty much have two solutions from it for it. One is altering the mesh the topology of the mesh. So if we would split up these with one here as well, we might fix it like that. But I wonder, I would really like to avoid adding more mesh data to it. Pretty sure it's a downward flow that screws us over. Okay, we have that problem as well, that's true. So when we fill it up finally, when we finally fill this one up, we're gonna walk around the edges and we're gonna we don't really see the river, we don't get the rivers we usually, or we did with the previous approach here, which I think is a little bit sad. Here we do actually. Yo, what's up, Lombex? Hope you had a nice weekend. Yeah, we're doing some improvements, definitely. Okay. Still worried about this one. Okay, so we have some few more changes to make as well before we start improving it. I'm not entirely happy with how it looks when we stop pouring. Sometimes so here, for instance, why do we fill up more than we previously did? This I don't like at all. I'm pretty sure that it has to do with walking. Yeah, when we walk on the edges here. Actually, let's see here. This one. Oh, never mind. It's because we don't reset. So this is actually a result from the previous one. That's true. I'm pretty sure. Let's try from the start one more time. Like walking along the edges doesn't really cost any water if the edges has the same water height, which can result in some weird result. Okay, there we stop, or we dry this one up because we didn't get the water overflowed, so we dry it up. It can be hard to see sometimes actually. So this isn't enough, this is enough. Do we have, yeah, here we go. We have some flow downwards here, that's nice. Okay, good, it works. It's just that we don't reset it between steps. So if we do this and stop, we get the same result as previously. Okay. But I want to add one more task. We're gonna put it here. Improve water edges. Maybe only tied to downward flow. I think so, or from what I've seen so far, downward flow is mostly where we get this problem. But let's see here now. Okay, I want to start, it's Monday morning, I want to start with some easy tasks, so I'm just going to clean up real quick here. We have terrain data, which is a class I thought we needed, or we were going to rewrite terrain data container, but we don't. So I'm going to delete that one, and then I'm going to rename terrain data container to terrain data. We're going to start with this one. As for this one, I'm not... Terrain data, terrain, oops. terrain data container. We have data pointers and we have data. Both are private, that's good. And let's keep it like this. I'm still a little bit worried about this one, and I'm gonna have to handle it later on. So when we create this one, we get pointers to the data, but according to the documentation, depending on how this one gets altered, updated / modified, that those pointers might not point in the correct data after some time. Not entirely sure how I want to handle that one. This one we're just gonna skip. We don't need to rename it. Improve overflow finder such that all the points get a fixed amount of water. Okay, let's see if we can visualize that problem so we can actually see what we're trying to fix. I think it has to do with... Okay, this is the minima finding, and I'm not so sure this one has the same problem. It looks pretty... Okay, let's see. Yeah. Okay, so for this one we get the same amount of water, but how does it look? Oh, I shouldn't have quit there. But okay, so I think it's the overflow. So when we calculate the overflow, the water surface height becomes like shorter and shorter, and I think I want to avoid that one. Let's see. So if we find a minima here and then we start overflowing, 139, 138, 36, 34. Yeah, exactly. So what happens when we try to calculate the overflow is we add one fluid unit to a point and then we disperse that one. If we don't find a stable state, or actually when that is done, we just increase the amount of... Fuck, but that is what we want to do. Yeah, it is. So I don't know, that task might, like, we want it to grow. Like if we have a hole in the ground and we start filling it up, we want to fill it up more and more. I wonder I'm pretty sure this is how we want it to be. Eventually takes a very long time here. Way too long. There we go. How long time did it take? Let's do this. I need some more information to get on, to go on. Although I wonder, improve performance by minimizing duplicated calculations. I think we definitely need to look into this one earlier than I initially thought. But. So what we could do is, when we check for fluid overflow, we could when this one fails, or this one fails, we add the point to a list that is pretty much end nodes, I would say. But then again, yeah, we add it to a list that is end points. So those are if we increase the water amount, those are the points we want to start with and spread from. But then again, the idea is that, because right now, let me draw this one to make it a little bit clearer. I can't really remember, but let's go with that one. So if we have actually, let me do it like this. So if we start pouring water into this one, we then spread to this, and then we might get, when we try and spread this one, here we succeed, here we succeed, here we succeed, here we fail, this one also fails. So this is pretty much the end we get, which means that the nodes we stopped on are these. So currently, the next time we iterate through the algorithm with so fluid amount plus fluid unit, we start from this one again, which means that we will recalculate all of these points. What we could do instead is we just store these points, so all the end points. So the next time we iterate through, we take whatever value we have in those points and we start spreading from those, pretty much. But then we're gonna have to yeah, we also have the problem that we add neighbors multiple times. That is definitely true. I think we want to add a check for that one as well. We don't want them to be in unvisited points. Yo, what's up, Fabic? How are you doing, Robin? I'm doing pretty good. A little bit tired than usual on mornings, but otherwise fine. Thank you for asking. How about you? Hope you had a great weekend, man. Yeah, so right now we might actually have one of the big problems with, although I wonder, this one should fluid spread get value. These will pretty much make it so that we don't add the same neighbor multiple times in the list. But yes. But yeah, let's say that we do one iteration of the algorithm. We get these endpoints, the red ones. The next time we do the algorithm iteration with more fluid, we should start from these red points and just ignore these. But that means that when we check these neighbors here, we're gonna go in this direction as well, and we're gonna calculate for these again. Yeah, that sucks. Fabric, I'm good. Nice to hear, nice to hear. So yeah, we can optimize this one, but it's gonna be a little bit more tricky than I initially thought. But then again, it's not really high priority for now. You could also like we have a list of affected nodes because we use it for updating the mesh, only the specific points. The only problem being that we affected points also include the minima finding ones. Okay, maybe should wait with this one until we have the other tasks done. Improve overflow finder such that all the points get a fixed amount of water. I think we're gonna skip that one, or that we don't want to do it. Yeah, keep finding minima visuals when we move to the next step. I'm gonna show what I mean by this one. Make it possible to exit check for fluid overflow early. Yeah, that one I know. But I wonder if this one we definitely want to fix. We're gonna add make moving diagonally during, or actually make moving diagonally more costly during find reachable minima. And that Fabric, that's not really how I wanted to end that sentence, but yeah. Let's fix this one first, because I think it's the easiest one, and we're gonna do it by adding update staple fluid. Let's see here. Calculate fluid spread amount from P to N. Fuck, we're gonna complicate this one a little bit. I wonder, let's see here. It's also a question of, I only want to do this when we move in parallel, I think. So moving, yeah, I definitely just want to do this when we move in parallel. So it's going to be for this one. That's okay. So let's do here, let's do a float. Diagonal cost multiplier. So distance is equal to I think this is the easiest way to do it. P.x, P.y. N.x, N.y. So we just take the distance between them, and since it's a grid, so from this one to this one, we're just moving one index. So we have a distance of 1, 1, and here we have, what is it, the square root of 2. So with what I want to do then is so this one is either 1 or the square root. I wonder if maybe diagonal cost multiplier. I wonder if we want to do distance. So if we do distance times this one, then we get, so then we just get dry constant when we move up or when we move vertical or horizontal, and we get square root of 2 times dry constant when we move in diagonally. But I want to include this one in some way. Yo, what's up, Crow's Eye? What do you do for full-time, mate? I'm a data engineer wanting to be a game dev as well. I do this half-time and then I work with data half-time. Not in a programmer role, though. Okay, so how do I wanna introduce this one in this calculations? Pretty much I want it to be I want this one to decide if we want to include a distance or not. We can do a simple branch if we want, but we should be able to do it with a simple multiplication. Nice, data's good field, but this more fun. Yeah, definitely, I share that opinion as well, but I also think data is, I've always loved data, like everything, statistics, whatever, and there's really no better time than to be in data right now. Data is worth more than gold, I would say. With the rise of the neural networks and stuff. I mean, we could just do distance minus, let's see here. No. What we want to do is okay, let's put it like this. This one we always want to include, but then I wonder, diagonal cost multiplier or moving diagonally. Do I want to have it as a multiplier or do we want to have it as a straight value? Remember that the data we're working with here are byte, so we only represent data between 0 and 255. So introducing a float here, it's going to yield a lot of, and we might just go with a flat value, honestly. And do So diagonal cost multiplier, and then we can do minus, and then I wonder if we want to do math dot round distance minus 1 times diagonal cost multiplier. And then, yeah, I guess we're gonna need to put this one to an int as well. So we always have dry constant, we always take this one into account. Depending on this one, we also include this one. And round, so distance minus 1, distance is 1 when we move vertical and horizontal, square root of 2 when we move diagonally. So this one is probably going to be 1, right? I guess we could do floor. So 0 for vertical, horizontal, 1 for diagonal, and then we have diagonal cost multiplier. But then you could also, we could just diagonal cost. Yeah, I think this is better. Appreciate the lurk, Fabic. So something like this. And now we have to introduce this one at all the different points. And we're gonna do it like this. Dry constant. Dry constant diagonal cost. Do I want to be more consistent? Dry constant diagonal constant. I don't think so. Yeah, gonna go with 1 for now. And we only want to use this one in this case. Terrain, fluid solver. Like this. When we search for overflows, we want to keep this one at 0, I'm pretty sure. And when we calculate the final fluid spread, we definitely want to keep it at 0 as well. Something like that. Let's see if we have fixed. This is just to make... but it's, I think it's gonna look like shit, unfortunately. Let's try it. Let's see what we have. So instead of getting a... when the water pours out from the point where we add it, we want it to have a little bit more of a round profile instead of a square, right? Wonder if this is enough. That's not really what we want to see. Okay, that is true. I didn't even think of that one. But if we take a look at this one, when we spread... No. When we spread from this one to this one... Okay, when we spread from this one... Yo, what's up, Victor? Thank you for the raid. Hope you had a wonderful stream, man. Let's see here. We have a dry cost of 1. We have a diagonal cost of 1. Dry cost is probably the naming I want to go with, by the way. So let's assume that we have a value of 10 here. We move here, so we have 9. We move here, we have 9. We move here, we have 8. But then the next iteration, when we move from here to here, we get 8 again. But that's good. What am I missing here? Okay, 10, 9, 8. Had a good time, nice to hear. Followed a while ago, not sure who I was lurking on, but the project looked cool. Appreciate it. Why am I unable to wrap my head around this? Diagonal cost 1. Oh, yeah. Maybe. Yeah, okay, no. I think. Or do I? I think it has to do with the fact that, let's just double check this one. Pn dry constant diagonal cost. I think it has to do with the fact that we're doing this later on. Victor, I'm a lurk for now though, been at it for 7 hours. Damn. That's nice. Appreciate the lurk. Yo, good morning, Geralt. Hope you had a nice weekend. Okay, basically what I want to do is, instead of having this as a square, I would like it to be more of a circle shape, you know, because we want to make it more costly to move diagonally. But the fact is, ten, 9, 9, 9. It should work like this. I wonder. 10, 9, 8. This makes me question if searching all 8 of the neighbors is actually that good of a choice. Would we just do it? let's do this. Let's just add a temporary. Let's add a. So when we search for minima, when all of this is done, we do. We just wait for max value or max int. I just want to see what kind of result we have, what actual values we have in this. Water temper 133. Okay, because we have a height of 128, we add 5 to that one. If we move here, 132, 132 here as well. Why though? Okay, so we don't take the... It doesn't cost extra to move diagonally. For now, at least. Did I screw something up when we did the calculations, or... Ooh, 1 sec actually. 133... By the way, I just realized something. This won't really work when we're working with terrain patches, because then we can have 2 points that are neighbors. One have px equal to 255 and the other one has it equal to 0. So we will get an extremely big distance, although the distance should just be 1. That is true. But that still doesn't explain why we don't have a diagonal fall off already. So this one does, what does it do? Abs of px minus, or actually it does px minus nx to the power of 2 plus py minus ny to the power of 2, add those two, and then the square root. One one zero one zero one to the power of 2. I don't know what I'm missing. Although, let's take a quick look at this one again. What actually happens in the end here? We add... Yeah, but this is just for the water. This is not water temporary. But will this one... Nah, it should be okay either way. What the fuck? So we're working with a grid here. The distance to 1 in vertical and horizontal is 1. I don't see it how it could be anything else. The distance to a diagonal 1 is square root of 2. I don't see how it can be anything else. We do minus... Ooh, yes, yes, of course, of course. Yeah, I'm gonna blame this on Monday morning. If we do... let's see here. Oops. Yeah. Or actually, no. Yeah, so we square... okay, though. Okay. Square root of 2, 1.4. We do minus 1. We have 0.4. We floor it. It's 0 as well, of course. So what we want to do is... In fact, we want to... we want to do... In fact, we want to do ceil. 1 minus 1, 0, ceil, 0, 1.4-ish minus 1, 0.41. We ceil it. That's how we should do it. Right. Given our... given the topology of our terrain, this looks like shit. But it's a tiny bit more spherical, I guess, or circular. Yeah. Okay, this is rough. And this is probably why we would like to introduce a float, because then maybe we can get this point as well. Okay, so the first like the first problem with making this water or this whole process pretty in the end, like the first thing I want to get sort of right is the edges of the water. So most of the time, let's quit this one and let's remove this one. Most of the time, okay, so when we have the stable state of the fluid, most of the time, or let me put it like this, when we have the stable state of the fluid, the edges are going to be fixed by the terrain. That is the idea, at least. So this doesn't look too bad, even though we have low resolution terrain. But during the process of finding this state, we're gonna have some problems. Oh yeah, we can't add water there, because in that scenario we want to visualize water that doesn't really have, it doesn't have terrain edges that decides its shape, but rather like it dries up, so we're gonna have an edge, but an edge that is not decided by the terrain itself. And when I see this, we might also, when we find the overflow, we might want to do this in a spherical way as well. But I wonder, will we be able to do it in a pretty way? Even though the topology isn't the best. That's what I'm wondering. So if we quit here, we actually get this. We get a nice little overflow into a little bit of a pond here. This stamp topology. Here we will always get an edge like this. And on the other side we will always get an edge like this. Tessellation, doing tessellation, and Tessellation could... Tessellation in the correct way could make it a little bit more pretty, but it's also gonna involve... It's gonna make it way more computational heavy. We could add... How could one do this prettier? It's the same problem here. Topology related. If we introduce a middle point for each quad and make each quad into basically 4 triangles, I think that would solve it. So, but that would add extra points to the extra vertices, extra triangles to the water mesh. When we read values from the water texture for the middle points, we could just do we could use the power of textures and just read a bilinear interpolation. So we use the 4 neighboring values for it. Yo, what's up, Fabic? I'm back. Stupid triangles indeed. This won't solve it, it will scale the problem. You will have the same problem. I'm trying to visualize it. Well, we're pretty much introducing a line here. It will definitely scale the problem. Do you think it will scale the problem? I'm wondering... I'm wondering. Let's see. I just want to make sure. Let's double check this real quick. You see the different bend options we get. Okay, it's been a while. So what do we have? So this is the topology we have right now, right? Which means moving this one down results in a nice something like this. Moving this one down results in this, which looks like shit. Let me just do this first. So moving this one down, moving this one down. Let's move them down by the same amount. Something like this. Maybe. So I think it will solve the problem. But then again, yeah, it should. But then if this one has this, so this one gets its value from 4 of its neighbors, so it should be pretty much 0.2, 0.05. We will get something like this, I assume. But if we let those be max value of its neighbors, then we're okay. Like, am I missing something, or will... But I mean, the complexity we add, it's a lot. Fabric changed the middle verts, not the edge ones. But, like... I think it's these we're gonna change, not the middle one. But yeah, I might be missing something. Yeah, if we change the middle ones, yes, then we have this problem, but... But if we take a look at this one, like, what we want to do is, like, for this example, this is the topology we have, and in this case we have changed these two vertices. What we basically want to do is we just want to make the topology more similar in both directions, which it is here, and then we change these two, much like we did here. We get a much better bend in that case. But so we would get a line what I wonder though, what would happen if so right now the topology of the water and the ground they have the same topology, like exactly one-to-one topology, because we actually clone the ground one and make it into water. But what if you reverse them, so the ground topology is in one direction and the water topology is in the opposite direction? So you would pretty much have 0.2 something like this. So you have one water and one that is ground. Could they work? Could that work in our favor? Maybe. I don't know. Could it? How hard would it be to check this? Let's see. Or to just do it real quick. Terrain patch. We want to jump to terrain patch mesh. This is just where we copy it. Okay, we want to jump to terrain. Oops. Terrain patch. So instead of going, when we create this one, instead of going, what do we do? IJ so instead of going this, we want to go this, or this, and this. Am I being too optimistic about this one? Like, I'm trying to visualize it in my head, like how would opposite topology, like, will it obscure it or will it enhance it? but we need to remember, like, having them as the opposite topology, it would only fix this problem, if it would even do that. But when we have water, when we search for a path and we're not getting cut off by the ground, then we will probably still have the same problem. But here, for instance, would it fix it? I think it might. Probably want to make this class generate its own mesh anyway. I want to try it. Why not? I want to add more options to this either way. It's gonna have the same position mesh data. Yeah, we're gonna share the mesh data. What do we do here? So I wonder, we could probably just move mesh data mesh. What do we do here? Instantiate, we send in a mesh as well. Mesh data, allocate mesh data native array, copy from, and then we just copy the mesh. Resolution -1. What do we have? Resolution times resolution. 6 times resolution. The nice thing with this one is basically we don't want to do this twice. Okay, I just want to try this real quick. So let's make it in a unoptimized way, and let's do this. Recalculate bounds. Mesh, 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 mesh. And then we just do... just do this, mesh, mesh water data, triangles water, trial index, water, but one sec, mesh, mesh. Let's do this one. We don't need to change triangles. Alright, and then we do instantiate water mesh data, mesh water data. Did I forget to mesh data? This one we want to change as well. Mesh water data. Mesh water data, mesh water, false. And then we're going to want to go, let's see here, what was it? So right now we go this one plus this one plus this one. So right now we actually do this. And we want to do this instead. So we want to change this one to J, right? Up, down, and then we want to go from this one. So I want to go J, and then we want to go up to this one, which is this, and then we're going to go. So we go from this one up to the right, and then we go from this one. One sec. We go from this one to this one, and then this one. That's right. How does it look? This one looks like this. Where do we have water? And there we go. Ah, beautiful. Let's see. A little bit more fine detailed. We don't have any change here, that's good. Going downwards. Is this salvageable? Actually, we also want to lower this one quite a lot. Maybe like this. I think it looks better, but still some artifacts I'm not that big of a fan of. I don't know. Here. I would love to let's see. I should have done this before, but let's just, like, I really want to figure out how big of a problem this might be. Like, how much do I really need to focus on this? And I want to figure out what kind of result we would get, or how it would look with some distortion or some displacement on the water as well. It is pretty rough. I'm pretty sure it's roughly this resolution we want to keep it at for the terrain and water. Maybe subdivide it once more, but that's if we could make it look pretty at this resolution, I would be happy. Yeah, when you have a height difference in the water, or when you have a height difference between two neighboring points, that's when the topology gets, or the intersection of the topologies gets highlighted. Actually, let's do it like this: 90. Do we actually have no difference? Hmm. This is not the best. comparison. Yeah, the problem is, let's see here, where do we have this one? 0.001. This makes me wonder. One nine 82 82. We've been here before, I think. I don't remember exactly what the... So right now this one is set to the maximum amount of water. Water 82, 82, 49, 62. Yeah, 39, 39. Yeah, I think I'm gonna leave this one for now. We're gonna do this. Could water edges be improved by setting edge nodes to minimum neighbor value instead, or minimum average neighbor value instead of maximum. So in this case that would be, instead of setting this one to 101, the water level, we would set it to either 64, that might look rough, but not the maximum at least. Yeah, what's up Derek? And yo, what's up Love? Hope you two had a wonderful weekend. Yeah, there's pretty much, I think we can polish the edge of the water in, like, when it gets to these parts here, we don't need to polish it because this one has the same water amount as this one, and like all the neighbors has the same water amount. But we have a special case when we have like a downflow, so we could either probably maybe improve it we could improve it using the algorithm, so like just extending the algorithm a little bit so we get better water values at edges, or like, I don't know, the more brute force way to do it would actually be to change the topology itself, but changing the topology itself, I see that more as a last resort basically. And Luva, how's it going? It's going pretty good. I think we left on a very good note this Friday. Made some very nice progress. But just before I quit the stream last Friday, we defined a set of tasks which are not the easiest one, and those are the ones we're working with right now. And I don't know if Monday is the best day to dive into those, but yeah. But yeah, then again, let's just add a little bit of a animated displacement here, and let's just see how it looks. If we're getting worse, like if it highlights it or if it hides it. Terrain, procedural, water shader. Let's see here. Properties, grid properties, water properties. Water distortion. Luvaha, yeah, sounds like Tuesday tasks. It definitely does. Definitely. I don't know, let's go with 0 default, and then I want water distortion time multiplier. Is that everything we need? I think so. Now let's add water distortion scale. Zero. Let's see here. I want to include some files. I think we have util, random util, math, lightning. Do we have random float? Don't we have util math? Unity gradient noise. Beautiful. We need a float too. Oh, don't we have a scale here? Ah, we scaled this one, I think. Yes. So let's see. We have 3 new floats. Let's put those here as well. And then we want to do it here. We calculate UV here. That's great. And then we do something like float 2, this UV distortion. In fact, we want to do, I think we want to do float 2. I want to do uv.x plus, what is it? Time. T divided by 20 t, so I guess we want to do time dot y, and we want to multiply this with, what did we call it? Water distortion scale, I think. And then we want to do float distortion is equal to, what did we call it? Unity gradient noise. Unity gradient noise, UV distortion. So if I remember, this gives us a value between 0 and 1. Let's double check. I think so. Derek putting some final touches on the water. Oh wait, this is the beginning of the water shader. Unfortunately, not quite yet. We have a few things I want to improve, but more specifically, like we have some issues here with, I would call them topology-based issues, and they are not really solvable by shader alone, I don't think. But like we're gonna have some distortion of the height on the water, not much though, but I just want to see if we do, how much of these artifacts get hidden, because I don't want to have jagged water lines like this. So I just want to do a double, like, do I need to focus on these jagged edges right now, or can we skip it? Okay, so I think this is a value between 0 and 1. And what we want to do then is we want to lerp, and we want to do it by minus water distortion height, water distortion height. Maybe. Okay, so if this is a value between minus 1 and 1, then we can just multiply it with water distortion height. Otherwise we need to do a lerp like this, but then again we can do this, I guess, to make sure. This is pretty much just the implementation of gradient noise you would get if you used shader graph. So we can do Unity shader graph Perlin noise or gradient noise. We might would have, maybe we, I don't know. Okay, they don't state it. Oh well. What's up, MSG? Let's just find out. It's not that important, I guess. Okay, so we have distortion, and we would probably like to do this before we do this. So we calculate distortion. Yeah, this is gonna look real ugly on water that is exactly the same height as the ground. So we actually want to limit this one to be water below this one. Oof, that's another problem we need to take care of. Maybe it's okay. We'll see. MSG, not much, looking for some game dev streams to motivate me. Been there. So let's keep this, and we do plus float 3 0 distortion 0. Uh, 126 6 UV, we want to do input. input. $29. Distortion height 1. What the fuck? Okay, yeah, that's too much. Let's do 0.01. 0.01. And then we do time. Actually, we don't use time multiplier for now. The one here. Yeah, it's probably just gonna highlight it, honestly. That's too bad. But it depends. Scale. Do we use scale? 10, 1, 0.1, 1. MSG still brand new, but found some sort of motivation after getting over a roadblock. That is always nice. Yeah, I had one of those this Friday, but now I'm back in the mud. Okay, let's see here. It feels like my scale. What do we have? Water distortion scale. Is this how we want to do it? Probably not. But first of all, I want to add water distortion time multiplier. And then I'm a little bit worried about this one. Let's take a look. Scale. Do we have scale here? They do UV times scale. Plus 0.5? Question mark. Why? So it's pretty much the same thing we do. MSG, sorry, was on ad break, so couldn't hear if you said anything. I just said that I can relate, and I had one of those. I would say pretty much the full last week was a roadblock, but on Friday we finally got over it. It was very nice. But now we're back at it. This 0.5 here, I question it. So basically, if we don't use scale, we get this one. We don't have anything with 0.5. If we use scale, I don't know about this one. Yeah, I'm pretty sure we're gonna highlight the issue. And this is way too much movement. And I also, later on when we do the final, I guess this is good movement for if it would have been a greater slope here, because that's the thing as well. If we have a static lake like this, we don't want to move the edge too much. It's actually kind of okay. But the end, like, the end point is that the artifacts we get here, the topology based artifacts, they are still very much visible even though we do this. Very much visible. Gotcha, my main roadblock was modeling, but I decided I'd go with voxel style graphics. Nice. Yeah. Like voxel styled graphics is I find it extremely pretty. But that's usually how it goes. Like it's the for game developers who aren't that comfortable with 3D modeling, they usually go something similar. But I don't have anything against it. Okay, so what this distortion implementation tells me at this point is that we need to handle the edges beforehand, either by changing topology or by altering the algorithm in such a way that we calculate the edge values of the water in a better way. But yeah, it's not gonna be easy. I'm not even sure. Like if we take a look at this corner right here, the artifact we're seeing is pretty much, yeah, it's always ground mesh decided, right? It's the same issue we would get if we alter the terrain in, let's go with 0,1. If we do it like this, so it's the same issue we can see here. You have this diagonal edge here and here, but here you don't. And of course, what would happen if we did some tessellation on this one? Maybe I want to try it. Yeah, I use programs like Blockbench and Magic Voxel for the models. Oh, so yeah, of course it does, but I didn't really think about the fact that there exists like 3D modeling software with the sole purpose of voxel graphics, but of course it does. Nice. I would think if it doesn't exist, I would probably like to do it as well. Let's see here. Blender add-on voxel graphics. Voxel machine. Okay, so it turns models into voxel-like models. Voxel draw. Derek, tessellation is a good idea. Slope corners could have thresholds for being tessellated. Yeah. I think that's pretty much the... Yeah, definitely. I wonder how much work we would have to put into... Yeah, it's pretty much what we're gonna have to do, I think. If we take a look at... Okay, let's just bring down the... let's put it to 0, and then we run far away. Yeah, I mean, like the jagged edges, they don't become a problem pretty early on. Like, just add a little bit of a distance, and they are pretty much not a problem. So we could tessellate it around here. Like, tessellation is extremely... It's quite heavy, isn't it? Let's try it. It's not too hard to implement. Yeah, let's do it real quick. Let's just pause this and take a look what we get from the get-go. Actually, now when I think about it, tessellation... This material already has tessellation based on us wanting to add grass, I think. Yeah. But we don't want to go as heavy as that. But yeah, let's see. So do we have procedural grass light shader, I think? No. Terrain procedural grass. Right now, however, we just do the tessellation based on yeah, we don't do anything complicated with the tessellation part. It's only the slope corners from the one axis too, so the cost of the extra geometry shouldn't be too bad. Let's just add a real... So right now we do terrain data UV. Okay, what we could do is... Let's just... Okay, that's a pretty sick... I just want to see... I think we need to do some extra Yeah, we have an extremely simple tessellation algorithm here. We need to alter. Yeah, we need to alter the. Like right now, the only thing we do is, given a triangle, we add more triangles on it. We don't adjust for height differences and stuff like that. But if we did, we can do it in a pretty simple way, I think. Let's see. It's in. Yeah, it's in here. Instead of doing position world space, we want to read from the height map. Yo, what's up, Wormius? Long time no see. We should be able to just do it here. Read from the height map into plate. Like, I'm just gonna do this extremely simple. First, we're gonna offset the height, and it's gonna be rough. I haven't done any more intricate or detailed tessellation before, but I've read about it. So use curves and stuff like that. But like doing a rough interpolation where we alter the height based on the height map will give us a better result. I just want to check how much better result, if we even need to do the more intricate parts. Wormy, it's good to see you. Likewise. What have you been up to? It must have been like half a year since you dropped in last time, I think. And right now we're doing a terraform system, including grass, ground, water, and stuff like that. And we have this problem where like the topology makes the edge between water and ground look jagged, and I'm just trying to minimize that. So it look more smooth, pretty much. But I wonder here, let's take a look. What do we do? Terrain data, we sample texture, we do it with UV. We scale the UV as well. So let's just do this real quick. Position world. No. I think we can do. We want to do it in the domain, right? We want to use this UV to read the height map, and then we want to change the position based on that one. So could we just do terrain data? We take UV, sample terrain data texture. So we sample it, and then we do something like position vs dot y is equal to, but then again, this is world space. So we're gonna have issues with Wormes, I'm working on a puzzle game. I published a demo to Steam already. Oh, nice. Nice. Feel free to share it in the chat. And I'm gonna take a look at it after the stream. I love puzzle games. Meme, yo 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 yo. What's up today? What's up, what's up? Okay, so the height map is a value between 0 and 1. We interpolate it between two values. Toggle tile demo, nice. I've always wondered about that on Steam. Like, you see multiple games, they have a separate, what should I call it? They have a separate Steam store entry for the demo, and then they have another Steam store entry for the full game. I'm just wondering if it's possible to keep the demo and the full game at on the same entry. Mem water shader today. We're gonna dip our toes in the water shader, but we have some issues to handle before we fully focus on it. Wormy, Steam only recently changed that. Okay. You can now keep the demo and the game. Steam changed it to be separate app. Okay. I'm just trying to think if there's any way around this than doing this. Height range. Mm-hmm. Test variables. So we do sample texture LOD, terrain data texture, sample terrain data UV, 0, and then we hit Y, and then we do lerp between height range.x, height range.y, terrain data.r. And that's the position in world space. So we're not going to get any shading difference or something like that from doing this. But yeah, let's see. So then if we do Height range 0 and 1. What do we have actually? Oh, fuck, we have 0 and 1. But am I doing this the wrong way? What happens if we do ground and we do... Okay, we do offset it. But... Worm's demos can now also have reviews. Oh, that's nice. So this shader is for grass. No, it's for the ground. We want to get a nice curve on the ground. So if we take tessellation, tessellation 0. So this is how our original mesh looks, and you can see that the triangle layout results in jagged edges when it intersects with the water, and I want to fix that by, or I want to see if tessellation can fix it. But to do that, we need to tessellate in the correct way. We need to offset these based on the height map. So it's yeah, I'm researching if my tessellation can remove these jagged edges. And Sam's might, many big games have failed recently. Yes, indeed. I actually read about the game Concord this weekend, and it's pretty sad, honestly. Yeah, I think players don't care that much about the game being big or small, just that it's good, definitely. But when it's a multiplayer game, it pretty much relies on having a bigger player base. But yeah. So you want it to be smoother without having too many vertices to save performance. Yeah, like we could just subdivide the base mesh, but we don't want to do that because that's gonna give us more vertices all over the place. Instead, if we could just subdivide it. This is something we're gonna do later on either way. We're probably gonna rely on tessellation for the terrain to make it more optimized. But in this specific case, we just want to tessellate it to see if we can get rid of these jagged edges in the intersection with water and ground. Samsung might tens of millions of dollars in 8 years spent on Concord and under 1,000 players playing it. Yeah, I read it. I think it even was $100 million, right? That's insane. And I mean, like, when I first read about it, I was kind of perplexed. Like, I wanted to see how it looked. Like, how the hell can a game with this budget and this development cycle fail that badly? It must look like shit or something like that. But, like, everything I see about the game, like, I mean, it's pretty... The gunplay looks very good. But it's, you know, kind of generic. But still, under 1,000 peak players on Steam. Yeah, that's insane. Yeah, Fabric, 8 years in development. Yup, it's rough. In fact, I thought this would be enough, but apparently it's not. But I think I know why. Sample texture to the LOD. I'm pretty sure. This has to do with the fact that terrain patch or terrain data, I'm pretty sure this has to do with the fact that instantiate data, textures, width, height, RGBA, filter. Oh, we actually do filter mode bilinear. Fabric, have you seen character customs? I mean skins, just different colors. Actually, I haven't, but that is pretty rough indeed. I think I'm just spitballing here, but there's probably, when it comes to Concord, there's like nothing that sets it apart from other hero shooters on the market already, and most of those are free. But yeah, I don't know. Fabric and the game has more pronouns than playable characters. Yeah, that's one thing I heard as well. Wormis, now I see a paid multiplayer game. Yes, indeed. It feels like in today's day and age you either need to have a nice brand behind it, or something very special about it for players to pay for a paid multiplayer game. Concord should have been free, but Sony got greedy. Yeah, I wonder if it's too late to switch it to a free. Like, what would happen? I think so. Making the game paid is less greedy, but I think they made it paid as well as a shit ton of microtransactions. I think. I don't know. Now I'm speaking on things I don't really have knowledge about. But yeah, it just looks bland to me. Okay, so we have filter mode bilinear, so why doesn't this work? I just want to try. I might be misunderstanding something with the tessellation here, but I'm pretty sure this isn't where we should. Let's see. 327. Or actually, yes. Yeah, this won't change anything. Because we could do... terrain data sample texture would be LOD. This won't really help us. We could also do plus unit gradient noise UV. I thought... Yeah, of course, but we want to do it with, I don't know, 0.1. But yeah, a paid game with more payment makes no sense to me. It's... let's go with a scale of 10 here as well. Like, I guess this could be a very... an extremely simple way of getting rid of... let's do it like this. Height range, float, 0, and let's name this one noise height, or height noise multiplier, and we do height noise scale. Yeah, let's do this. Height noise multiplier and height noise scale. Let's try this. Line 95. Yes. Yo, what's up, Smack GDs? I always forget if I should say God or not. Not, I think. Sam Smite, how many years of experience have you got in coding shaders? Probably wrote my first shader around 2015. And then it was extremely sparse for a long time. So it's hard to answer. Okay, height noise multiplier, height noise scale. Let's try this one first and do 1. We get something like this. That's too much. 0 0.1, 0 0.1, 0 0.1, and then we do 10. I thought we would be getting more of a 2, 3, 4, pretty. I don't know about this though. 100. Yeah, this would probably help. I mean, you could do it in such a way. I mean, this is one approach to minimize the jagged edges, but you probably want to do it not a big fan. Nah, not a big fan. Yeah, we definitely want to introduce like when we do the tessellation, we don't want to do it linearly on the heights. We want to do it based on some curve, based on neighboring vertices and stuff like that. Yeah, this to solve this with tessellation is, I think it can work, but it's going to be way more complicated than a straightforward solution like this. Oh, actually, one sec. Am I tired or am I tired? That is the wrong material we want to change. Here we go. Yeah, like I could probably find a middle ground like this, which somewhat solves the issue. But yeah, I don't know. Custom tessellation. Yeah. Probably not the way I want to go about doing this. Like this specific tessellation. Like this more, I think, except for this part right here. Like, it's not too bad. It's actually not too bad. What if? Water 55, water 64, water 70. Okay. What the hell happened here? Water 55. Here we actually get the smallest value. Interesting. Do we just... 70, 55, 64, and we get 55. If we did... Okay, we can't do that. Like taking a look at the water here, the lowest point has 55. This point has more. This one point has more. This one has 55. If we were to... I want to try a different approach. I want to try an approach where we take... but then again, let's see here. First of all, I want to... uncomment this one and... comment this one. It's not too bad. But like, if we could solve this, if we could get clean lines much like this one, purely on adding more control over this value, could we? Yeah, we could. Definitely. Basically, we want to... okay, we want to get to these endpoints. If we reach one of those endpoints, we add water amount to it, but we loop through all of its neighbors and check if their neighbors has water that is bigger than its ground height. We add them all together. We add all neighbors that for which that is true, and then we average that water height. So this vertex right here would get a, instead of a water height of 55, it would get, what do we have, 70, 55, 64, probably around 60 something. So it would mean that it is a little bit higher up, but this is just for this specific case. And then we have the water here. So this point and this point would be a little bit higher up, right? Let's see if it's true for 55, 64, 80. Yeah, so for this one we would also go a little bit higher. We would probably go more to 68, and I think that would... what do we have here then? What do we have here? 72, 84, 72, 70, 70. Definitely want to average this point as well, but this point has water that is less than ground. Okay, so we want to take all neighbors that has a water value that is bigger than 0 and average them, I think. But. Maybe. But how would that look, for instance, here? 135, 35, 35. Probably. Or maybe we don't care about all neighbors. Maybe we just care about this neighbor, the diagonal one, right? Or 55. That's the one we have right now. That gives us a bad result. But maybe... yeah, maybe we shouldn't care about the diagonal one and just care about the direct neighbors. So this one, this one, this one, this one. Basically what we want to do is we want to make this water bend we want to make it, we want to bend it like a quad instead of two triangles, I think. But what would happen on the opposite side of things? So it's pretty much in this state, and if we spread, okay, so if this is true, we spread it. Okay, so if this is false, that's when we want to do additional calculations. So we could pretty much add this if before we do this one, and we set this to spread and we compare, and if it's true we set water to fluid spread. If it's false we set it to an average of its neighbors. The problem being, depending on the way we traverse this grid, the neighbors may or may not be set just yet. But then again, the last neighbor is always going to set this value as well. Not if we have this one. That is true. But, okay. Yeah, what we could do is... We could add a check outside of this if. We can check this one. If neighbor get value water is... Nah. Okay, calculate fluid spread. If fluid spread is bigger than its current. I wonder if we do if fluid spread is bigger than this one, then we set it. Otherwise, if it's bigger than water, let's see. If increase water and visible water, then we set it and we add it to unvisited points. Else if do I just want to do it like this? If okay, so we can add water to a point. That water we add is more than it had, and it is visible. We can add water to a point, but it's still less than it had. So else if increase water and we don't have visible water, I don't know. Actually, I don't know if I could probably do it like this. I don't know if there's a difference between or if I want it to be a difference between increase, like if the new water amount is less than the water and it's not visible, or if the new water is more than the current water but it's still not visible. I don't think we want a difference between it. Okay, so if we don't have visible water, so here we increase the water and it's going to be visible. Then we set the value to terrain data type water. We set this one to be equal to fluid spread, and we add it to unvisited points, because this means that we will spread this one further. Otherwise, we have come to an end and basically want to average out the water. But we should be able to do n.set value terrain data type water, and we set it to n.get value terrain data type water plus fluid spread mathf round to int. We also want to divide this one with 2.0. Which means that every end node will have a water amount or water value that is equal to the average of all incoming water sources, basically. Or But then again, one thing. I don't know if it's the fluid spread we want to set it to. Fluid spread. If we move downwards, that might screw it up a bit. We might want to change this one to p.water actually. Let's see what we get. And we want to fix that as well. Okay. Why? 0.01, yeah, maybe. Okay, this is weird. Yes. One sec. Yes. Increase water, visible water. Okay, so yes, this is just if, yeah, we want to do one additional check here. So right now we actually flow water into a node, and if that flow results in a non-visible water, we actually lower the water, even though it was visible before. But that doesn't make any sense with increase water. Yeah, we actually want to do if increase water and visible water. Let's see here. Oh. Yeah, we're gonna have to clean this up, make it a little bit more straightforward. But this should fix that issue, I think. So if it's not visible water and it's already not visible, then we do this. No, never mind. It's N we want to do here, right? But then, and we want to do height here, I think. Already visible water, N dot water is bigger than P dot height. Visible water is if the new, yes. Increase water is fluid spread speed, and maybe. Water 23, 26, 22, 30. 23? Ah. Yes, this one actually has... Oh, that's true. This one actually has a water value of 0 the first time around, so... We get... Let's see here. The value I want to get is... What is it? Let's take... this one. 26, 22, 30. 26, 22, 30 divided by 3, 26. But we get 23. Is that because we get... $30 divided by 2 plus 22 divided by 2 plus 26 divided by 2, something like that, yes. Hmm. I don't know. 26, 22. Would it look that much better with... Wish I could alter 46, 30, 30, 5. Here we actually get something. Here we get the correct value, but it still looks like shit. If not visible water, already visible water. Let's do. I wonder if this is. So we just set it to the max value. Terrain data type, water, and we want to set it to a fluid spread. Then I guess. So it's not going to result in visible water. It's not already visible, but we're going to increase the water amount. Then we set it to. Then we set it. Maybe. We could probably test these different approaches in the shader instead. Just read from the water texture, and then we wouldn't need to recompile it every time. But yeah, and we could put it would be much easier to compare. That's for sure. Hmm. 31, 45, 36, 44. Well, 1 sec. 45, 44. 51, 51. I don't know what the hell happened here. We lost one. Rounding error, question mark. Fabric, hey Robin, sorry for the distraction, but I have sent you a picture with an idea. Maybe it could help. Oh fuck, I do want to check this one out right now. But I don't know. I'm a little bit afraid of opening Discord. Would it be too much of a hassle? Could you send me the Discord link to the image in the chat here? I don't know. Oof, maybe you. I don't know what the auto mod for the YouTube chat is, if it allows for links or not, but like if you could send the, because I don't want to open up Discord. I don't know which server I have opened and so on. Yeah, but like if I'm gonna open up Discord, I don't know if it opens on this, like on the screen I'm currently streaming or not. Which would show people I have on Discord that maybe don't want to be shown on stream, you know. But if you could just link the Discord image, and hopefully it won't auto open my Discord, I don't know. Or just an Imgur link would be the most preferable, I think, but that's a little bit more job. I could disable screen for a sec. Okay, let's do it. Let's do it like this, and let's do it like this, and back to stream. Okay. How about building the mesh like this? So it's a question of, instead of building, oh shit, now I have two here. Let's remove this one, and where do we have set 0? The fuck do I still have? Let's do this. So let's see. What the hell? Let's see. So let me just see if I can visualize this. There we go. So right now we have it like this. This was another idea, to have it like this, which I think gives a good result. But what you're saying is that, that we do it like, let me take a look. Something like, let's see here, that we do, can I dissolve this edge? We do it like, oops. do it like this instead. But. Like, even though this would still yield the artifact here, right? Like this, we don't increase the triangles, we don't increase the vertices, we just change the topology a tiny bit. But thinking G said minus 0.2, J 0 minus 2. This would result in a cleaner result than this, but the best is still this one. But this one has more vertices and triangles, right? So like, this one is definitely the best. But if we did, what if we do this? Just a minute, two. Yeah, this one. Oh. As for the terrain issue, I'm pretty sure this one is this is much preferable than this, definitely. But I'm wondering about this one right here. I'm wondering if it still solves the edge case. Oops. Or is there something I'm not seeing here? This one still comes with the same problem. But then again, let's see. Two. So this is what we would get. I wonder. Don't allow odd spilling radius. Yeah. I mean, like overall, fuck, this topology is definitely preferable to this one, right? Right? We get the same issue. If we would dig like this. Robert Pattinson, what's up? How are you so good with everything in life? I'm not. But thank you, appreciate it. Ooh, 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 ooh. Ooh, ooh, ooh. Wow. But actually, if we would have... What the fuck? Yeah, this one, this one, this one, and this one would go. So we don't actually set these. They take the average of its neighbors, but so would this one. I get fucking topology, man. I still think this one is preferable to this one. Let's show it a little bit more. I have to think about this one. So 5. This one, this one, and this one, and this one. We don't set these values. They are only read from the... Or do we? Yeah, they are only read from the texture. Like, they don't have a... What I'm trying to say is they don't have a specific pixel value in the texture, but rather their pixel value comes from interpolating the neighboring pixel values. So in this case, 0.25, and this one as well. So in this case, z minus mm, 5 divided by 1/25. What do we have here? 116. I wonder what would happen if you go nuts. Let's see here. Easy, thank you so much for the follow, appreciate it. 116, 116. What if you did? What if you did? 121. I want to try so many things. Okay. $79. I wonder. Honestly, I wonder if it's all about. I wonder if it's all about. One sec. Let's take this one and let's jump to let's jump back to this one and we do let's disable that one and we do subdivision. Yeah, we calculate subdivision here. I don't know, let's do 1. Actually, not 1, but 2, I guess. What do we do? Partitioning integer. Let's see here. Or actually, is HLSL tessellation partitioning? Can be integer, fractional, even, fractional, POW2. I need a better description. Don't we have examples? We have the edge function has on 1 1 1 1. So what if we do 3? This is what I want to achieve. Edge factors of 1 1 1 1, and do we have this? Is beautiful. What is the formatting here? Following mesh. What about edge factors of? Okay. 1. Is it the integer one that screws it up? One sec. Now we have edge, edge, edge inside 1 1 1 1, and but I'm wondering about this one. Partitioning, what partitioning do we have? How is someone supposed to read this? Here we go. This is partitioning integer. Output topology, triangle, CV. Do we need to do... Okay, wait. Edge factors of 1 1 1 1 and inside factors of 2. Where? One, two. I don't know. Do we have any better resource than this? I think we had a... Fuck yeah. do. One sec. One. We want to go 2, 2, 2. Fuck, what do we want to do? Do we want to go 2, 2, 2, 1? Is that what we want to do? 2, 1. No. Or actually, maybe. Two. What I'm trying to get at is if we could tessellate it in such a way that we get a result like this. Our mesh isn't actually like this, but when we're close enough to it, this is what our mesh appears to be. And let's see. Oh, actually, let's do. And then, so we don't actually have this one. Oh, one sec. This is what we have. We want to split 0 or 1, I guess. 1, 1, 2. Is that what we want to go? 1, 1, 2, 1. I don't know. Let's just learn by brute forcing, I guess. So let's split this one into something like this. The question is if all of them has the same order of things. I don't know. Hercules. Thank you for the follow, by the way. And Thunderfix squares, indeed. That's all it is. On some level. And Thunderfix, appreciate the follow. Oh, unexpected token. Yeah, let's add 2 of these. Yo, what's up, Hercules? How the fuck do we get this weird? Bum, bum, bum. Yeah, okay, so we split. We don't split this one, we don't split this one, we don't split this one. Hercules, what are you working on right now? We're working on some terraforming stuff for this game. And we have pretty much implemented a fluid solver. So we can add lakes and rivers to our terrain. But the resolution or the topology of our terrain and the topology of our water doesn't really see eye to eye. which means that at certain points where the water intersects the terrain, it doesn't look that nice. It looks a little bit too jagged, and I really want to get to the bottom of that. Of course, the most straightforward way to solve it is to just, when we generate the mesh, we just generate it like this instead, which will at worst decrease the jaggedness, but at best remove it altogether. But I don't want to introduce more vertices and stuff like that in the actual data. So I just want to tessellate this mesh on the GPU. So when we're close enough to it, we tessellate it to give it some extra vertices, and we adjust them instead. It's sort of complicated. But yeah, I think... okay, so here's the thing. I need to run now. I've been going on it for 4 hours, but I will pick this up right where I leave today. Like, I don't know, my understanding around tessellation isn't... It's pretty limited in such a way, so I don't know if we will be able to tessellate the quads in the exact way I want to tessellate them. But I'm going to take some time today to read up on tessellation, and tomorrow when I stream, hopefully we can get the tessellation correct and see if it fixes our problem. We have so few issues left here before we can just improve how the water looks. I'm looking forward to it. I hear you, Fabic. Great stream, appreciate it, and thank you for the help as well. Every little input counts. Do you upload your VOD somewhere I'd like to watch? Yes, I have them over on my YouTube. There should be a link in the Twitch description. Or I have links to my videos, or my devlogs at least. But I have all the VODs on my YouTube as well. But yes, so thank you so much for watching, everybody. Always appreciate it. And have a great rest of the day. Peace.